What's up? CJ here. In this video, I'm going to talk about C# specifically for TypeScript and JavaScript web developers, and I'm going to talk about how you can get started in learning and building things with C#. Now, this video was inspired by episode 781 of Syntax. On that episode, Scott and I were answering viewer questions, and specifically one viewer asked, what language should they learn next to kind of branch out from JavaScript and TypeScript? And my answer for this was C#. So let me tell you what you can do. I'm going to link this document down in the description. It has a ton of links to where you can get started with all of this stuff that I'm going to talk about. But the first thing you'll need to do is set up your local environment. So I'll link to that article there. It tells you everything you need. Also, you'll need to install the .NET runtime, so you can click that link there. And then there's also the C# dev kit for VS Code. So that gives you everything you need inside of VS Code to be able to write C# programs. Now, I have a tiny little learning plan for you here. And the first step in all of this is to familiarize yourself with the C# language. There's a lot of things you can do with C#, but I would start with just learning the syntax and building out some basic programs. And so let me show you some of the syntax right now. You can see here, if we want to output to the console, it's just console.writeLine. We can pass in a string. Strings in C# use double quotes. Semicolons are required. But you will see this looks very similar to TypeScript and JavaScript, and that's because C# is a C-style language, just like JavaScript and TypeScript are a C-style language. And so this is how we output to the console. We can also create lists of strings. You see here I have CJ, Wes, and Scott in this list here. You also see that I have the var keyword. C# is not a dynamic language like JavaScript. Var is actually just a shorthand. The type here still is a list of strings, but we can use var so that way we don't have to type out the type name on the left-hand side. Similarly here, name is going to be a string, but we can use the var keyword, and they have string interpolation. So this looks very similar to template strings in JavaScript, although I would argue a little bit cleaner because you only have to have one $sign. But that's the basics. You can create lists. Foreach is built in so you can iterate over them. It's pretty slick. One of the other cool things about C# is this thing called language integrated query, or LINQ. This is kind of like map filter reduce in JavaScript, but you can operate on arrays and lists, and you have Lambda functions. So even though C# is an object-oriented programming language, you can still do functional-like things, which is pretty slick. So here I'm grabbing all the names from that list whose length is greater than 2, sorting them, and then spitting them out to the console. Another cool thing in C# is pattern matching. And so I first came across pattern matching when I was learning Rust. And this is really cool because it's more powerful than just a regular switch statement, because the thing you're matching on can be an actual expression. And so this here is a Lambda function. That's the other thing, is we can define Lambda functions in line. And on the left-hand side, we have an expression that's going to be evaluated for the thing that we're matching on. And if it evaluates to true, we'll run the expression on the right-hand side. And so, for instance, we can invoke that function, pass in 32, and we'll get back that specific state, then output it to the console. So pattern matching, pretty slick. And then another really cool thing about modern C# is this idea of records. So if you're familiar with creating classes and objects like in Java and also in C#, which you can still do, this is similar, but much, much less code. And so the idea here is you can define a record of some type. You define all of the properties that it needs to have, and this is all the code you need. So this is a whole lot less boilerplate than like creating a class and a constructor and like fields and getters and setters and stuff like that. This one line of code is all we need to create a class with 2 public properties, first name and last name. And then we can create instances of it. We can output it to the console. It's really slick. Now, there's a lot more stuff in C#. I just wanted to show you some of the cool modern features of C#. So you should definitely check it out. Now, here in the resources, I have various places where you can go learn about C#. And one of the nicest things is pretty much everything you need to learn about C# you can find in the official documentation. So Microsoft has put a ton of work into making sure that the tutorials are good, the documentation is good, the resources are good. So they even have entire free video series on learning C#. So definitely check out the C# for Beginners video series, learn more about the language, and it's a full series that's going to teach you everything you need to know about the basics. Now, beyond that, I would practice with C#. And one of the ways I like to do that is with Code Wars. So go on Code Wars, pick some of the easier problems, and just try to solve them with C#. Because from there, you're going to learn about some of the built-in methods and ways of working with data types and stuff like that. So I would start there. From there, you want to start building real applications. And I would focus my efforts on ASP.NET Minimal API. Let's take a look at it. Because if you have ever built an Express API, this is going to look very similar to you. Essentially, you can define a web application and then define your endpoints. So this says when a get route comes into / respond with the string hello world. and then run the application. And so this is, like I said, this is going to be very familiar to you if you've ever written an Express app with TypeScript or with JavaScript. And let's actually generate one really quick just to see how it works. So in this directory, I'm going to make a directory called minimal API. Go in that directory. And then if I say .NET new web, this is going to create a super basic minimal web application. We'll open it up. And if you look at the codes, it's exactly like that example we just saw. But if I start it up, I can say .NET run. So that'll start it up on my machine. And now I have a working web API. And I can add new endpoints to it. So for instance, I could add a to-dos endpoint. So we could say like map get. If we go to /todos, this is just going to be a little Lambda function that returns a new array of strings. So we'll have something like learn C#, learn.net. Boom, I've got a new endpoint. Now I will have to restart this, but the CLI comes with a watcher. So if you say .NET watch run, this will automatically reload anytime there are code changes. And so now our API is up and running, but if I go to /todos, it returns a list of to-dos. You'll also notice that it automatically stringified it into JSON. So modern C# and like the minimal API here is really slick, and you're definitely going to like it if you're coming from like Express or different things like that. Now, another cool thing built into the .NET ecosystem is Swagger and OpenAPI integration. So now that I've defined this API, I probably want some kind of documentation that says, what are the endpoints? How do I call them? And in the world of JavaScript and TypeScript, there are some packages that'll let you do this, but it's a lot more manual. But there are integrations I can add that I literally just attach them to the builder here, and that will automatically generate documentation for this API. It'll say what endpoints exist, what data does it accept. And so I recommend check out the minimal API's overview, and then they have this tutorial, create a minimal API, and they'll walk you through creating a full CRUD app for to-dos, and they also add Swagger and OpenAPI integration. From there, you're going to probably want to talk to your API from a JavaScript or TypeScript web application, and because it's a REST API, you can do that with fetch, but you probably want some kind of type safety. And the nice thing about Swagger and OpenAPI is that it generates a specification for your API. And there's a whole ecosystem of tools that can take that specification and generate a fully typed client that you can use in your front-end JavaScript and TypeScript web application. So actually, let me show you an example of this. I'm going to pull it up really quick, and I'll show you what that looks like. So for this application, I went through that minimal API tutorial and built out a to-dos API. But you'll see that they add a bunch of other stuff that you typically will need for an API, things like talking to a database. And then I also went beyond that and found their tutorial on adding authentication and authorization. You can see that we here have the Swagger generation and OpenAPI document generation. We also integrate with Sentry, which I'll talk about in a second. And so basically I'm adding all the things that you would need for like a real production level API. And from there, you can see our actual endpoints. So if I look in routes, I have a file called to-do item routes, and then I have a function for all of our CRUD routes, right? So get all items, delete an item, insert an item. And you'll see what we're looking at right now is just C# code. I don't have any extra stuff that tells it like how to document this stuff. These are literally just endpoints, and then I map these endpoints to specific URLs. But that's all that's needed to generate an entire spec for this API, right? Like, I don't have to do anything extra. I just have all of the code that defines the endpoints, and then in my setup of the app here, I've enabled OpenAPI and Swagger. But from there, you automatically get this Swagger UI. And because I added that identity, you can see that I have endpoints for registration and login and email confirmation and password reset. All of those endpoints automatically got added just by adding this identity integration. And then from there, you can see that it documents all of my to-do items endpoints, and it tells me the type that I'm going to get back here. And when I'm making a post request and I try it out, it gives me an example type here because it was able to infer that from all of the types, and it was able to generate this entire spec in documentation. And so if you're new to this actually is based on the OpenAPI spec. You can see the spec that gets generated here. But this is actually what's being used by Swagger UI to be able to know what all of my endpoints are. But one of the cool things is once you have an API specification like this, you can generate a typed client. And so let me show you that. I have here a React application, and I used this thing called the OpenAPI TypeScript CodeGen. And so essentially all I had to do was pass it that OpenAPI specification, and it generated an entirely typed client that I can use now in my React application. So you can see if I do service dot, all of these endpoints are fully documented, and I can call them here from my TypeScript app. So all that to say, even if you're building your backend with .NET and your frontend with TypeScript, you still have a way of integrating those two and having good type safety between them, which is really nice as well. So that's your learning plan. familiarize yourself with the language, build yourself an API, follow the basic tutorial, and then start going from there. Now, like I mentioned, the world of C# and .NET is really, really big. So definitely check out the rest of the links in this document where I talk about those kinds of things. So one of the things you should be aware of, though, is in the past were a lot of different versions of .NET. These days, it's the .NET platform and .NET version 8, which is what we're using, but you might come across old things that reference .NET Framework or .NET Core. These days, we're specifically talking about the .NET platform. Now, another thing to be aware of is with ASP.NET, there are other ways of building backend applications. So they have things called Razor Pages, MVC, and Blazor. Those are a lot more involved. I will say it's a bit harder if you dive into these first before doing something like the minimal API, if you're coming from a JavaScript or TypeScript background, because there's a lot more that it entails. But these are ways to build backend applications as well. The other cool thing about .NET is you can build other things. You can build mobile apps, you can build desktop apps. So I have links to all of that, and also game engines where you can use C# to build applications there as well. So hopefully this is enough to get you going and get you out there learning C# and .NET. But another thing I want to point out is how we can track errors in our applications that are built in this decoupled way, where maybe you have an ASP.NET backend and a TypeScript frontend. And so we can do that with Sentry. So Syntax is brought to you by Sentry, and they are an error monitoring platform. They allow you to track issues in your production applications that are running. All of the errors that happen will get sent here. They'll get grouped together, and you can also see how often they're occurring and when they're occurring, and they have a lot of other built-in features as well. But one of the features I want to highlight is full stack tracing, because if you have a backend written in a language like .NET and a front end written in a different language like TypeScript, without something like Sentry, it can be very hard to figure out when an error happened on the front end, how does that actually tie into the back end? And Sentry can do that with full stack tracing. So for example, let's look at this error that happened here in this app I was building with a .NET backend and a TypeScript front end. Request failed with status code 500. And we can see here that this specifically is the front end error. If you click on view full trace, we can actually see where this happened in the loading of everything. So I have a client-side application that had a page load. You can see it loaded all of our assets and everything. And then there was that request to the backend here. But because I have the Sentry SDK installed in my backend code and installed in my front-end code, I can now see that, hey, that error that happened on the front end, that's actually linked to an error that happened on the backend. And we can see that there was an exception in my .NET code here. So this is one of the really cool things about Sentry is not only do you get error tracking, but even if you have multiple applications that are all communicating with each other, if you enable tracing, you're going to be able to see where that error originated and how it made its way to the backend as well. Integration is super simple. So in my backend code, all I have to do is say use Sentry, pass in my DSN and specify all of my settings. And then in my front-end code, I just say sentry.init, choose which integrations I want, and it takes care of the rest. So it'll automatically attach headers to like outgoing requests so that this integration is automatic and I don't have to do anything else beyond this sentry.init. So even this auto-generated client here is able to trace those requests to my backend without any extra codes, because all I had to do was just add this browser tracing integration. So if you're not using Sentry in production, you're flying blind, and it's probably really hard to debug your errors. So do yourself a favor, check out Sentry. If you go to sentry.io/syntax, we have a code, Tasty Treats. You can get 2 months free, so definitely check it out. All right, that's all I have for you in this video. Like I said, check out this document. I'm going to link down in the description, and go forth. Start writing C# code, learn .NET, and let me know what you build. And leave a comment down below if you are going to learn C#, or if you have some favorite things about C# that I didn't mention in this video. All right, I'll see you in the next one.